Hello explorers and welcome to another video. Today I'm gonna talk about different file formats to the JavaCNN that I built a few months ago, and this has come up due to a question I got from Musamil Hussein, who writes, "Hi Daniel, I'm working on JavaCNN project. Could you please let me know how I can prepare data for face images 19 times 19 images? So 19 squared. And then I replied and asked a little bit more what he actually had, file formats and so on, and what his actual problem was, and I got a response back. I actually need to know how I can make these NIST-like training data from my images. I have face, non-face images in PGM format." So let's go to my code here, and let's first off look at the definition for PGM, because that's a quite interesting one, and here we have that. And PGM specification format, are quite funny. The PGM format is a low and common denominator grayscale file format. It's designed to be extremely easy to learn and write programs for. It's so simple that most people will simply reverse engineer it because it's easier than reading the specification. So this specification says pretty much that you have a magic number, you have some white space, and then you have a width and height, and then you have some white space, width, and then some white space, height, and then white space, and then the maximum gray value, maxval. So this is the ASCII decimal that is the largest that you can have in the file, and then you have a single white space character using a new line, and then you have a raster of height rows in order from top to bottom. So this is pretty much all the values after that. So I have changed my setup a bit in the NIST test here, so I can have different readers. So what is a reader? A reader is an interface that could read the next label, because we had that before. We could read the next image as int, and an int array. We can reset, so if we have read all the images or we want to start over and read from the top again, we can reset, so we can start over again. We can ask how many images there are. We can ask how many classes there are. For instance, in my example here, I have two different labeled classes for the PGM and PNG files. And for the NIST data, it's 10 classes, because that's all the numbers. And then I can get the max value. So that's the max value in gray scale that we read from the PGM file. And all the PGM file I have a max value of 255. The NIST data have 255, and also the PGM files that I will create later also have 255. But you can have a larger range there. And when you come into the NIST set, I actually want to divide by that to get a value between 0 and 1 to have as an input into my model. And then we have the X and Y size, so that's width and height of the specific image that is going in. And let's just fast look at the add image data here. It takes a new image and it takes the max value now. So here before we just divided by 255, now divide by the max value. So that's the change there. And if we look at the NIST reader, it's pretty much unchanged. We still have something that reads ints up here, and then we have the size that I have since before, how many images we have, and then we have some startup initialization. This constructor will set the image and label file, and then prepare them for reading. We now return the max value of 255. We return the number of clauses 10. The reset hasn't changed. Read next label and read next image haven't changed. And I have a main function here, so I can actually test run it. And this width and height function. So let's go to the PGM then. If we look at the actual constructor here, we take an image path, and in that directory we go through a list of all the files in that directory, and we create labels from everything before an underscore. I'm not sure if you can see my images here, but in this list I have 7 dog images and 7 face images. So this is 1 to 7 of dogs and 1 to 7 of faces. So before the dash underscore, we actually have the name of the label. So I will fetch all the labels, and then I will create a list of all those labels. So first I will add them to a set, so I will get just the unique label, so I don't get any duplicates, and then I will add them to an array so I can easily fetch them later. And then I will go through the first file in the list, because I depend on that all these files are the same width and height and has the same max value. So I will fetch those values in the from the first file in the directory. So I will open this file up with a buffered reader. I will read lines from it, and the first line should be the header. So I check if I get P5, which is the header on that line. So if I ever get a P5, I will return true. If I ever get a comment, I hope it's just hash and something that it's a comment, then I will just continue, and then I will read the image size. And this regex says that I have some numbers 1 to 9 x number of times. It must be more than 0, and then I want blank space, and then I want some numbers again. And if I have that, then I will actually fetch it, split it by space, and add the image size and in both x and y as parsed ints of these splitted strings. And then I will look if I get a line that just has has numbers and nothing else. Then I will fetch that and parse it into the max value. And if I get anything else on any of the lines before I get anything of this, I will throw an exception, unsupported file format. And I will add to the header size. This is the value that adds how many lines until I get to the actual data. And if I have read the max value, if I found the header, and if I had found the size, I will break this while loop. So I will just read until I fetch the full header of the file and I have all the data. And I will close this up. So this is my constructor. We're reading the essential information that I need in order to read this file. Other things I have up here defined. I have defined 2 booleans, so I will know if I've read either the image or the label. And then I have a current image iterator, an int that I will keep track on which image I am on at the moment. So if I've read the label or the image, this will not be incremented, otherwise it will be incremented. I have this private function that will increment the counter, so it will set both the read label and read image to false and increment the current image. If I read the next label, I will check if I have read label before, then I will increment the counter first. Then I will get the file name from my list of file names. I will fetch the label index of this file name's first, the first part of this file name. So then I will get a number back, and if I have read the image, then I will increment the counter after that. Otherwise, I will say that I've read the label, and I will return the label back so I know which integer label that I actually got it as response. Reading the image is pretty much the same up here. If I have read the image before, I increment the counter. And if the current image is larger than the size of images, then I will return no data, because that makes no sense. Should have had maybe something up here as well as a safeguard, but then again, if it crashes there, you should never get the error that you can't fetch a file. Then you have done some logic wrong in your in your program, and the data will not be correct anyway. So this is probably not good to have. Then I will read the file name, and I'm opening a file input stream and a data input stream, so I could read specific bytes from the file. I start up here and say that the header size, so the number of lines that I read and actually found the header, I will set that to number of new lines. And then I will go through here and read bytes until I found bytes of new line character that many times. So let's say that I found a header of 5 lines, then I will look for 5 lines until I'm done here. And when I have read all the images, all the header data, so I will go past those. Then I create this return array with the image size, so x times y, and then do a for loop and read all the bytes in the image. So I will get an array or an int array full of unsigned bytes. And after that I have read the image, so I will increment the counter if I've read the label before. Otherwise I will set read image to true, and I will return the data. So this is how I read the image. Reset, then I reset the current image to 0, and read label and read image to false. Number of clauses is the number of labels I have. The size is the number of files I have in my file names list. And then I have this data that I read from the header. And then I have a main function to actually fetch the or try the functionality out. So this is my PGM reader. I actually went through and built an image reader as well, so I can read PNG files. And this is very similar. Up here, the image reader constructor has pretty much the same logic for the labels at the start. Then I fetch the first file name. I use a buffered image reader, and I get the width and height of those, and then I set my max value to 255. So this is a very short version to get the same kind of header data that we read from the file earlier. And 255 might be the wrong value if you have set your image up in a specific way, but I think it's correct because I will read the image and create a copy of it as a grayscale image, and I think the max value there is 255. So reading the next label is a pretty much identical function. So when we are reading the next image, we fetch the file name, we get the original image, we create a new image of the same size and a buffered image type byte gray. So this is a single value for each pixel in the image, a grayscale in a byte size. And then I get the graphics of this image, so I can actually draw something, and then I will draw the original image on this new image, and that makes a copy of it. So after that, I will create my image data array, which is actually, this is wrong here. It should be image size X times image size Y. In this case, I used the same value for X and Y, so it wasn't that big of an issue, but it should be right? So here I will create the buffer first, and then I will get all the pixels of the image data buffer. So this will get me data raster data, and then I will get all the pixels from that. And I need to supply a buffer of image data that it can fill, and then it will return the same buffer when it's done. And this buffer I will return from this function after I have incremented the counter or set the red image boolean to true. And the other functions here are similar as in the other one, and I have my main function to actually try this functionality out. And if we go back to my test here, I have set it up now so I read my PGM reader, and if I start the MNIST test, it will start off here, and when it have run for a while, it actually gets 100% right at some point, and it diverges back and forth a bit, and I think it's not perfect anywhere, but it's better than guessing, I guess. But my setup here has so few examples, so I think it's very hard to train it and actually make it good at deciding between if it's a dog or if it's a face, and it's quite a silly example as well, but I thought it was the easiest way for me to fetch some images so I can try this out and see that it's actually doing something. And just by creating these two new readers, I can use all the logic I had earlier in my setup here. One of the different in my input layer before, I sent in the size of 28 times 28 pixels, and now I need to actually supply the size of the image that I have fetched from the reader. So that's one difference, very small difference. And the fully connected layer, I have actually added number of classes to it, so it will diverge down to the number of classes instead of 10 that I had earlier. And down here where I print the predictions, I actually give it the number of classes in the predictions instead of just doing a while loop of for loop of 10. So that's why I can print number 1 and number 1 and 0 as predictions. I could actually go into the reader and fetch the actual labels, so that could have been a better output perhaps, but I didn't take the time to do that. So that could be an something that you can do if you want to build on this. I hope that I answered the question from Musamil, and I hope that you learned something in this episode, in this video. And if you haven't subscribed yet, please do that. I make videos every Monday morning, and please give this video a like, share it with your colleagues and friends, and I really hope to see you in the next one.